Good evening. My name is Scott Harris, and I am the staff planetary geologist for Fernbank Science Center in the Jim Cherry Memorial Planetarium in Atlanta, Georgia. I'd like to welcome you to our May 1st, 2020 edition of Your Sky and Solar System, our second installment in our new virtual at home planetarium show that we hope is temporary. Tonight's a very special show, though, because at the end of our Star Talk, we're going to be able to do just like normal in giving you a full presentation of the planetarium show called Solar Superstorms. We're able to do this courtesy of our partners with Spitz Incorporated. We'll talk about how to view that at the end of the program. But for now, let's turn our attention to the evening sky after sunset. We're going to look off to the west southwest between 9 and 9:30. And as we do that, we're going to see rising above the treetops three stars that most people know as the belt of the Hunter Orion. Above the belt, we find two bright stars, including the 10th brightest star in the night sky, the red giant star, actually, the red supergiant star called Betelgeuse. That name actually means the armpit of Orion. Betelgeuse, it's been a strange year for Betelgeuse. Back last fall, it actually started to dim and got dimmer and dimmer, so it was like the 26th brightest star in the sky. We didn't know what was going on, but now we think that the star was expelling a lot of dust that got in the way of its light, and that some of that dust cleared out by late February and it started to brighten up again. I always say if you have a great hunter in the sky like Orion, you have to have a great hunting dog. And his hunting dog is farther to the south here. This is the big dog called Canis Major. If you can't see a dog there, look for his bright nose. That bright nose is Sirius, the dog star. That is the brightest star in the nighttime sky. So my astronomer friends joke that it is, well, seriously bright. As we move the opposite direction from Orion, we find another very bright object, brighter than Sirius, but it's not a star. That is our sister planet, Venus, with the sunlight reflecting off of its white cloud deck. As we move a little bit higher in the sky, we can look for another bright star. This is Procyon. It's the brightest star in the little dog, Canis Minor, which is mainly just composed of these two stars. So my astronomer friends joke that looks more like a hot dog. You might notice that if you connect Procyon to Sirius and Sirius to Betelgeuse, you form a triangle in the sky. This is called an asterism. It's not one of the defined constellations, it's just a shape, in this case, a triangle. We call this one sometimes the winter triangle to distinguish it from the summer triangle that we'll talk about probably in a few weeks. If you take that triangle, though, and kind of treat Betelgeuse and Procyon as the ends of a bow, and imagine an arrow drawn back to Sirius and let the arrow fly, it's going to run right into the chest of two famous warriors. This is Pollux and Castor, the Gemini twins. Their heads high above Orion, their legs dangling down toward Betelgeuse. If you have a hard time seeing those patterns that the ancient Greeks and Romans saw in the sky, that's one of the reasons planetariums exist. So that with the click of a few buttons, we can help you out. And so now we see those twins, we see the dog, we see the hunter. Did you know there's actually a unicorn in between? We might also notice just above Venus tonight this sort of hexagon shape with a very bright star called Capella. That is the brightest star in the constellation of Auriga, the charioteer. If you still have a hard time seeing those patterns, we can always help you out with a little artwork to get some idea of what those ancient astronomers had in mind setting those pictures into the sky. I want to go ahead and go up a little higher in the sky. I'm going to remove our artwork and our lines. And as we move up toward the top of the sky that we call the zenith tonight, we see a super bright object. That would be our moon. that we call Luna. Luna is in the constellation of Leo the Lion. You'll notice this backward question mark wrapping around the moon. That's the head and the mane of the lion, attached to this rectangular body with a triangular tail, sort of drooping behind. Again, if you need help, we can fill in those. And again, you see Leo there marching his way off to the west. I'm going to go back down to the horizon so it's easier for us to turn our bodies around and look north. If you don't have a compass to know you're looking north, you can immediately know you're looking north by looking at the stars. And as we move up high toward the zenith again, we find a pattern everyone knows. There are 4 stars here in the shape of a pan with a curved handle attached. You might notice that the Big Dipper is actually not a constellation, it's another asterism, but it's part of a constellation we call Ursa Major, the Big Bear. To find the rest of the bear, you have to sort of follow that tail, that's the handle of the Dipper, down to a back leg with 2 toes at the end. You might notice that the back leg here is, the backmost leg is defined by 2 more toes. And there are toes out here defining the front of the bear as well. You probably know that if you do a little trick with that dipper, you can find a very special star called Polaris, the North Star. Again, so you know you're looking north. To find it, all you have to do is take the 2 stars at the end of the pan, shoot straight down to the horizon, and you run into Polaris. That is the end of the tail attached to the back of Ursa Minor, the little bear, or it's the end of the handle of the Little Dipper. I'm going to turn us eastward now. As we look up above the horizon early in the evening, we see another bright star. This is Arcturus. Arcturus is at the base of Boötes, the herdsman. But if you have a hard time seeing a herdsman, I'm going to show you a much simpler way to know you're looking at Boötes and Arcturus. If we take those lines and artwork away, we find a diamond. It's like a kite. And so if you follow the tail of the kite down to its end, there's Arcturus, like the little ribbon, like the bow at the end of the ribbon at the end of the kite's tail. I want to stay looking east, but I want to advance time now. I want to go into the future. We're going to advance an hour at a time. We're going to go from 9 o'clock to 10 o'clock to 11 o'clock to 12 o'clock, 1 o'clock, 2 o'clock. I promise not to break into song there. As we approach between 3 and 4 o'clock in the wee hours of the morning, we'll notice rising there in the southeast 3 stars in a line. Well, those aren't stars. Those are planets. Starting at the southernmost point, the highest one, that is the king of the planets, Jupiter, with the ring world Saturn behind, and then our closer red rocky planet, Mars. We'll talk about Mars later in the summer because we have a very special mission launching this summer to Mars. It won't arrive until February of next year, but it's carrying with it a new rover called Perseverance. I want to concentrate on the king of the planets tonight, that's Jupiter, because if you can see Jupiter there in the early morning hours, grab your binoculars or grab even a small telescope and take a close look, because we can zoom in on Jupiter. If you have a good telescope, you might be able to see the lines defining the different cloud layers in its atmosphere. But out beside it, you're guaranteed to see 4 bright dots. Those 4 bright dots are 4 of the 79 moons of Jupiter. But all of them, except for the 4 you're looking at, well, they're just kind of lumps of bits and pieces of leftover asteroids captured by Jupiter's gravity. These 4 are big and round spheres that really planetary geologists consider planets in their own right. They're differentiated, just like Earth. That means they have different chemical and physical layers. And that leads to geologic activity, including volcanism. So these are really special worlds. They're called the Galilean satellites or Galilean moons because they were discovered with one of the very early telescopes back in the 1600s by Galileo Galilei. If we look in order, at least in this view on this night, we find out to the right of Jupiter, we find Ganymede. That is the largest moon in the entire solar system. It's actually larger than the planet Mercury. Ganymede is a world that has a very young surface, defined by smooth plains and interesting grooves. It almost looks like some sort of crude plate tectonics existed at one point in the history of Ganymede. And we think that's exactly what happened. But rather than thick continents and even ocean crust like we have here on Earth, we have slabs of ice moving across warm slush underneath. Very different than Ganymede is her sister Callisto, that actually lies a bit farther out from Jupiter in its orbit. Callisto is an ancient battered world covered by impact craters. It doesn't show signs of much recent activity at all. But if we want to talk about really active, we have to look at the two closest to Jupiter, Io and Europa. Io is the most volcanically active body in the entire solar system. Hundreds of volcanoes, many erupting as we speak. It sends enormous lava flows flowing across its surface. It has so much activity because it's in a constant tug of war with the gravity of Jupiter and its sister moons. And so the inside stays warm and gooey, and magmas are able to erupt out basalts, just like we have on Earth's seafloor, onto its surface. In many ways, Io is much more Earth-like or terrestrial-like, more akin to Mars and Venus and Mercury than any of the other objects in the outer solar system. Like Ganymede and Callisto are more like those objects you find out toward Pluto. They're big balls of ice. Sort of in between the terrestrial planets and those ice worlds of the outer solar system, we have Europa. Europa is truly unique. We have an ice shell above a liquid, salty water ocean. And that ocean likely is kept warm and liquid by volcanoes deep underneath, just like having volcanoes on Earth's ocean floors. We have volcanoes, again, activated by melt generated by gravitational or tidal forcing of the interior. And it's that heat from the volcanoes, the liquid water, that gives us some idea that there could be simple microbial life on Europa. And so it's going to be the subject of many more missions, including in this decade, the Europa Clipper mission that will go there and literally sniff plumes of water erupting from inside of Europa, trying to see if there's the chemistry in those plumes that indicate living organisms. So I'm going to come back out to our evening sky here. Zoom on back out. And I thought before we look at our feature film that we would answer a question that is often asked of us in the planetarium. And that's where in North Georgia or in the Atlanta area can we go to get a truly dark sky, to see a view like I'm showing you right now? Well, we often recommend one of the probably the closest dark sky area to the metro Atlanta area. The John Wood Astronomy Field at the Charlie Elliott Wildlife Management Area. That's out to the east of Atlanta on Interstate 20, actually just to the south of the interstate in a little town called Mansfield. That's just to the southeast of Covington, Georgia in Newton County. The astronomy field is kind of managed not only by the Wildlife Management Area, but by the Charlie Elliott chapter of the Atlanta Astronomy Club. If you're interested in the field and the educational opportunities that are there, I encourage you to go to the website for the Charlie Elliott chapter of the Atlanta Astronomy Club, and you'll find out everything you need to know about how to access the field and be part of many of the programs that the club offers. I just wanted to show you what it looked like last night as I took my camera out and with a tripod and a 20-second exposure looked at this view of the southwestern sky there as the sun set. As we mentioned before, we see Orion and Sirius. Orion here, Sirius, and as we move up toward the top of the sky, we find our moon shining brightly there in Leo. You might notice a lens flare. There's no UFO or anything there. Sometimes people take wonderful shots of sky objects and they see these lens flares and don't know quite what to make of them. But it's just an artifact of the light flooding in the lens. We see again there Leo. Look for that backward question mark over near the moon. And I thought I would share with you here a little close up I took of the moon. And we see the moon just after first quarter. And we will find across the moon here the edge of the Imbrium Basin, Mare Serenitatis filling another large impact basin, the lava plains of Mare Tranquillitatis, that is where Apollo 11 landed a little over 50 years ago, right here in the corner of that basalt lava plain. And then over here we find Mare Crisium, the Sea of Crises. These are all dark lavas filling in ancient impact basins. They aren't really related to each other, except that the more ancient impact basins provided easy pathways for magmas to come up and erupt onto the surface of the moon. The basins themselves are between about 3.8 and 4 billion years old. The lavas erupted a few hundreds of millions of years after the basins were formed. And so with that, we'll look there to the north and see that Big Dipper and Ursa Major. But now I want to direct you to this website. You'll see it also in the comment lines for the YouTube video. And I invite you now to join us in viewing Solar Superstorms, a fantastic planetarium program produced by Spitz Incorporated. And we're very happy that they have provided that to us. If you really enjoy it, please let us know, and we'll see what we can do to purchase that for future full dome viewing in our huge 70-foot diameter planetarium. So again, thank you for joining me this evening. I hope you enjoyed the program. Please enjoy Solar Superstorms. If you do have any trouble viewing it, please feel free to send me an email or comment. My email is scott.harris@fernbank.edu. Again, thank you for joining us in our second installment of our virtual planetarium show. And we have another opportunity coming up next Friday. That will be on May the 8th. We're going to do everything we can to have a super special evening where rather than releasing our video at noon like we have this week, we're going to wait until 7 p.m. and have an actual YouTube Live event where not only will we be able to view the evening sky virtually, but we will present another full dome, well, in this case, flat screen full dome planetarium show I'm very excited about called Super Volcanoes. Not only will we show that, but I'll stick around afterwards on YouTube Live to answer any questions that you have about super volcanoes and volcanoes in general. So again, thank you for joining me. I hope you enjoy Solar Superstorms.